Okay, going into the hex body for P6-11. Again, we've already seeing it in half. We're going to draw whichever quarter makes sense. Looking at this, there is a missing dimension at the bottom. Looks to be like about a millimeter, so we would say that that's 16 millimeters. And so we're ready to start sketching our shape. So a new part metric. Front plane, open the sketch, go into the center line. I want it to be vertical and infinite length. And there was a miss. So when I miss, I'm just going to, nope, not going to be able to drag it. We're going to do the select, control select, make it coincident. And we'll bring the geometry off. Let's see, this is 100 millimeters, so we'll get close to that. We have 22 millimeters and then a little bit of a ledge, and then a little bit of a ledge, and a step, and then we'll come back. And on this one, I'm going to leave this last leg out so you can see what happens when we tell it to close off. Closing off the geometry is really not that big of a deal unless we're going to, say these were construction lines, or we're going to cross over existing geometry. All right, anything that makes this sketch self-intersecting is not going to produce a result. So 100 will go into the diametral, and outside is 36. The top is 22. All right, we said this bottom would be 16. All right, and then we have to do a little bit of calculation for the minor diameter of the thread portion. Metric easy enough that we go take the 20. We chose a 2 millimeter pitch. 20 minus 2 is 18. So we can build that out, and then we're ready for heights and an angle. All right, so on our drawing we have to the step 21.5 to the center of the M6 hole, and then 24. So when I place that dimension, let's get back into it. When I place that dimension, I can do that math, but I would rather just let the modify box do it. So if I do 24 plus 21.5, I get 45.5. And then we're going to go to center line for the angle, standard drill point being 118. Because I only have the half angle, I'm going to have to, again, calculate it. So 118 degree drill point divided by 2 gives me 59 degrees. And since that one's set at angle, I did not know it would do the A for angles. So that's kind of interesting. 4 millimeters to the step, and then 28 millimeters the body. And which one did I grab there? Oh, and let's go up. And that one should be horizontal to make the step. All right, so that looks pretty good. Just a quick check of the drawing. Got the shapes, the up, the over, and the other step. Okay, so we're ready to revolve this, and it's warning me that it is needs to be a closed sketch. When I say yes, it's pretty much just adding that line in. So we don't see it now, but once I complete, we go back in and edit it, and you're going to see that it connected those dots. Right, so if it finishes, then then great. If it doesn't, we'll do it manually. So, all right. So the inside, if I go with the cosmetic thread, let's type this in. Let's see. If I type in cosmetic, then I can left click and drag it into, if I'm using it enough, I'll drag it into the features, and then it will just exist there. If not, well, we can always go back to the insert, all the way down to annotations, cosmetic thread, pick the inside. It found an M22, and we want to go to M20 by 2. Also of note is this pretty much throws the thread going to that shoulder. That is not going to happen. There's always a partial, just like was kind of worried about it being a partial thread at the bottom. There's always going to be a partial thread because of the shape of the tool. And that we're not going to, even if I run if this is on a lathe, if I run the boring bar with a thread insert all the way up close, there's going to be half a thread that doesn't engage. If this is a thread mill, then we could, again, have half of the thickness of the thread mill. And even if we 3D print this, we could get it, but I mean, really, what are you able to do? So if it is something that needs to seat and thread all the way to the bottom, then that's where we'll usually put another groove in the undercut. All right, so the M20 by 2, and up to next, so it can show it. But realistically, if we're doing this geometry, good mechanical design, we're going to calculate what that offset, what that thread depth really needs to be. So let's go to hidden lines visible, and not really going to see much there, but we'll go ahead and accept it. All right, so you can see the major diameter goes all the way to the base, and we'll revisit that when we do the assembly, because the 3mm on the bottom chamfer, some of that's going to seed into this center, and so we would probably be a millimeter or two up that we really needed the threads, or we would make the decision to make this a little deeper. Usually looking at something like this, it's like a pressure valve or a some kind of regulator that we're designing, so we would take that into consideration. All right, so same thing. If I hide my cosmetic thread, and I'm only really hiding it to be able to easier tell what I'm selecting on the geometry. And yes, we'll stay with the warning. We have an edge up to selection. That one's a little harder in wireframe to make. Let's go back over to shaded with edges. All right, so it's oh, it's not picked. So I deselected that one. Make sure you have your boxes highlighted in blue. We'll go that way. All right, we're switching from the metric die to the metric tap because now we're going to cut internal threads. It has the M20 and the cut, so let's go ahead and jump back to, all right, so that one cuts a little bit into, so we could offset, or I could reverse the selection. So let's see, the offset is going to go that way, which we are going to need to do the 2mm, and reverse it. So that one is to the bottom edge. And then when I offset, reverse it to the top, And again, I'm just making sure that this cut completely cuts the geometry, that it doesn't just do a partial. All right, so let's go ahead and save this at this point. And apparently I wanted to rebuild something, so we let it. All right, so back to our display state, and we will start looking at the whole wizard. So the recommended for the M6x1 is a standard pitch, or most common pitch. We're going to use the planes first, and then we'll look at doing a 3D sketch. All right, so if I go over to my reference geometry, pick a plane, and did not pre-select, let's go to the right plane and make it parallel and tangent to the cylinder. All right, so that's kind of the long way. Make sure that that is selected, the whole wizard. We are creating a metric thread, so once I pick that it is a straight tap and ANSI metric, don't really worry too much about the bottoming tapped or tapped hole. We're going to move from the M20, that would be a little on the large side. Let's go to the M6x1, and in condition will be up to next, and then the thread depth will be up to next, and we do want to see a cosmetic thread. I very rarely use just the tap drill diameter. I don't think that I've ever had a good use for removing the thread. So we'll go ahead and set the position. Since we're on the plane, I can place that first dot, my point. Wherever I put a point, I'm going to get a threaded hole. So be careful about those selections. And we'll put a dimension. Actually, that was from the top. And on the on this side of the part, it is 41.5. And it's still able to move side to side. So I need to create a vertical relation to the origin and then finish it. All right, so somewhere I created a plane, either intentionally or unintentionally. So I'm going to hide that. And plane 2, it doesn't matter that it's plane 2. We'll go right plane. In this case, I'm going to hold down the control button, select on the plane, and drag. It's one of the instances where, depending on what's going on, you can end up with a plane and not necessarily know where it came from. So we have tangent to the cylinder again. We'll rotate around. The plane is still highlighted. Go into the whole wizard, and we'll set check that we are in the straight tap, metric, bottoming tap, and 6 up to next. All right, all of our settings stayed. So I'll make the vertical first this time, and then jump into the smart dimension, and then this is going to be the 21.5 millimeters, and accept. All right, so as an alternative or as an option, let's hide the plane. And I'll go ahead and suppress the M6. All right, so as an option, if you didn't pre-select, we go into the whole wizard, all of our settings are there. I go into position, you see the 3D sketch. It may be tempting. I'm going to say at least until you are familiar with the 3D sketches or familiar with the relations, stay with creating the planes. You'll have a lot more control and it'll be a lot easier to deal with. But as an example, if we go into the 3D sketch, notice that I can place this threaded hole anywhere on the cylinder. So I want to get it close, and I think I'm rotated about opposite. All right, so notice that I have an XY. I'm still in the points. When I shift, then I need to for whatever geometry I'm drawing, I'm going to see that floating origin. So let's see if I can make that vertical along Y. I didn't like that. Let's see, if we go Control 8, it will let me go normal to something, and then I can rotate to it. I'll try one more time looking at it that way. Still doesn't like it. All right, so let's make this normal to the plane. All right, so front plane, and this is going to have two possible solutions. I want to make it on the plane, so that positions it this way. All right, so now it's not trying to rotate around everything. And then if I dimension, well, it jumps to the center, and all I get is that linear center to center. Same if I was to go to the origin. So in this case, I would be looking at the center line. I can start at that point. There's my floating origin, and I draw a vertical, and it picked up coincident to that edge, which is what I wanted. And now I have something that I can dimension the 21.52. And it does the same thing, but I have to manipulate. Now there are times where the 3D sketch, because it's on, it's going to be more difficult to create the plane, then would go ahead with that 3D sketch. All right, so that creates our hex body. We'll look at some of the options that we have when we get into the assembly. So we make sure to save it, and next video will be the